name is Karuna Singh. Welcome to the channel North Star Continuous Knowledge Excellence. In this video, we will get to know about the fabrication of working electrode. Now, our expert, Professor Himadri Bohidar, who is associated with National Center Excellence in Agro Nanotechnology, Delhi Daikin Nanotechnology Center, India. He has 31 years of academic experience in teaching and research. His area of expertise includes nanoscience and nanotechnology, nanobiointerface science, soft matter science, polymer physics, biophysics. Will explain you in detail about this topic. So, to get complete information, watch full video without skip.
Now we have to make the electrode. So the gold electrode is chosen here. You take a gold electrode, it can be a gold wire. First, you clean it with the aluminum slurry and wash it with the deionized water to remove all the greasy materials on the surface. It can be heated and cleaned further. Okay, leave it under sonication to take out all the micro impurities sitting on the surface. Then make a silver nanoparticle dispersion in water, and then the gold electrode can be dipped into it, or you can do a drop casting method. Both are equally good. Leave it in dry air for about an hour for it to dry up. And then after drying the modified gold electrode in a very dilute Nefian solution, is deposited on the surface to provide rigidity to the electrode. Okay. And then you dry it up and this electrode is ready for detection of nitrophenol. Okay. So this is the picture of the silver nanoparticles here. The typical size about 24 nanometer. Some particles have a bigger size, but they're more or less about 20 nanometer in size, in diameter. UV visible spectra is get a clear spectra at a 420 nanometer value, which correspond to the bluish region of the spectrum here. You can see it here. This is a signature footprint of silver nanoparticles. This is the FTIR data from there, and this is a TGA data about the thermal stability of the silver nanoparticle. It's a very stable nanoparticle, and the XRD crystalline information indicating that the particles have very high crystalline structure. Beautiful crystalline peaks are there in this material. So these are the characterization of the gold silver nanoparticle first. Then you do the SEM exam analysis and also the EDEX to realize that this is gold silver and nothing else in it.
Wait. Are you worried about your project, training, dissertation, internship? Don't think too much, because Nanoscience and Technology Consortium, in short NSTC, is giving you a golden opportunity to do the same tasks. NSTC also conducts workshops on amazing topics. So if you want to register in the workshop, the registration link is given in the description box below, or you may go to the website www.nanoschool.in, where you can easily enroll in the workshops. So just check it out right now.
Now, after exposure to the analyte, you see that nitrogen has started appearing there as a component, which was not there earlier. In this thing, silver, oxygen, and carbon were there. Now we have nitrogen in it in some concentration. This is after exposure to the analyte, okay, which is the nitrophenol. Okay, we'll now do the electrochemical detection of this one. So this is the bare electrode. This is impedance analysis, bare electrode. And the electrode with after modification, the behavior is almost remain the same. But now when you modify the silver nanoparticles, now you see there is a redox signature already seen on the surface. So this is now ready for use. Now when you now exposed it to the analyte, then you see there is a specific anodic current, also specific cathodic current here. And again, to ensure that the electron transfer process is diffusive, you do either anodic or cathodic current test as a function of square root of the scan rate, and you get a straight line, which is seen here, which again says that you have a diffusive process of electron transfer inside the material, and the material is exhibiting redox reaction. And now from the analysis of your electrochemical data, you should be able to create a calibration plot for this one. Now, this is, you see the current value corresponding different voltages for different time periods. And see, there is the signal strength is quite sharp, stable, and then when you see a drop, this is where the voltage is applied to it. There's no voltage, stable. When the voltage applied again sharp drop, stable. Voltage applied again, sharp drop, stable. Sharp drop, stable, sharp drop, which basically means it's responding to the bias voltage very nicely, which basically is a test of the sensitivity of the electrode. Similarly, again, at the concentration of the analyte, you have the current, anodic or cathodic current there. Nice linearity is there. Sometimes this is also plotted as a reciprocal of the current versus reciprocal of the concentration, like this. 1 over current, 1 over the concentration. Again, a beautiful straight line. So either way, it's a calibration curve. Now, this analyte, in presence of other interfering elements or interfering compounds like ascorbic acid, hydrogen, potassium iodide, glucose, ammonia solution. This is the signal for our sample, our analyte. Okay, this is P nitrotoluene here. And for others interfering cations, you see there is nothing. The signal is not there. The dominant is this and this only. Others are hardly contributing to it. They're seen as the background as basically noise. So it's not sensitive to detection of potassium iodide, glucose, or ammonia, or ascorbic acid, or hydrogen. So this also implies the specificity of this technique for the detection of nitrotoluene.
I hope you liked the video. Here, I would like to give you an important information that Nanoscience and Technology Consortium, or NSTC, organize the nanotechnology workshops on amazing topics. Also, I would like to tell you about the initiatives of NSTC in which you can also be a part of. Mentorship, patent commercialization, joint product development, research projects, consultancy services, nanomaterials for your research projects, training programs or customized training programs, workshops or customized workshops. One more thing, and that is, if you want the full recording of the previous videos, so you can contact us on info@nstc.in. Further, if you want to enroll in the upcoming workshops, then you can go to the website www.nanoschool.in. And yes, subscribe to the channel Knowledge Star and hit the bell icon to never ever miss an update. Thank you.
For more updates, subscribe to our channel, click the links shown on the screen to stay connected.